Hey guys, welcome back to Hustler's algorithm. Today we would be solving this problem trapping rainwater. So you can go through this problem statement, but what it says is we are given an array of some positive integers and this integers represents some elevation, and this is shown in this 2D diagram, which is a 2D graph. And here we have to tell that how much water can be trapped between this element, which is this elevation. Okay, so let's see how we can solve this. Let's consider this case for understanding purpose. So we are given this input array and this contains some elements, and these are all positive elements, and this represents elevation. Okay, so we draw a graph which will be a bar graph, and here each element will represent a bar which is having some height which is equal to this element. So for 4 we draw a bar of height 4, for this 2 we draw a bar of height 2. So we will do the same stuff for all the elements. Now let's see how we can solve this. Let's first see what will be the water which will be trapped here. Now we can see that this complete portion will contain some water. Okay, so here we'll be having some water. So the amount of water which will be stored here will be this 4 minus the height of the bar which is at this position, which is 2. So 2. So here we will have 2 units of water. Okay. So here we will have this upper limit as 4 and 4 minus 0, because as there is no elevation which is a bar. So we will be having 4 minus 0 is 4, and here we would be having 4 minus 3 which would be 1, and for here we will have 4 minus 2 which would be 2. Now for this first and last bar we would not be having any water because there is no bar on its left or right side which can actually store the water. Okay, so the total amount of water trapped between these elements will be the sum of this, which would be 4, 5, 6, 7, 8, 9, which would be 9. So let's cross check our answer. So yeah, we get the output as 9. Okay, so let's see what's the logic behind this. Now let's start from this first bar. Now we can check that what is the highest bar on its left side and what is the highest bar on its right side, and we will check this for all the elements. So we will write the left highest and right highest here. So for this element we have nothing on its left side, so the highest on the left side would be 0, and on its right side we have the highest as 5. Okay, now for this element 2, on its left side we have the highest as 4, and on its right side we have the highest as 5. Okay, great. Now for this 0, on its left side we have the highest as 4. From this 4 and 2 we have 4 highest. Okay, and now on its right side from this 3, 2 and 5 we have the 5 as highest element. Okay, so same for this 3, on its left side we have still this 4, and on its right side 5 again. Okay, now for this 2, on its left side we are having 4 as highest, and on its right side we have 5 as highest. Okay, now for this 5, on its left we have the highest element as 4. Okay, and on its right side we have nothing, so we can write 0. Okay, so this is something which we have on its left and right side of every element. Now we will just consider this empty bar, and the amount of water stored here would be till this point. So the amount of water stored would be 4. So we can see that the total amount of water which can be stored at a particular index would be the minimum among the elements to its right side and the left side. So for this 0, we have the leftmost bar as 4 and the rightmost bar as 5, and the minimum among them is 4. Now let's take this bar. Okay, so here the minimum among the left and right height would be 4. Okay, so the minimum is 4 here, but the amount of water stored here is 2, which means this part will not store any water because it is having a bar. So the total amount of water stored is 4 minus 2, which would be 2. So this is same for all these elements, as here the minimum is 4 among 4 and 5. So the amount of water stored here would be 4 minus the height of this building, which would be 3, and so the amount of water is 1. Great. And here it would be 2 because the minimum is 4 and the height of building is 2, so the amount of water is 2. Great. Now for this first building, the minimum among the left and right bar is 0, which is this left bar. So the total amount of water stored here would be 0 minus the height of this building, which is a bar, which is 4, which is minus 4. Okay, now if we get any of the negative water storage, then we will not include it into our answer. Similarly here for this building 5, we will be having the minimum as 0 and height of this bar as 5, which would be minus 5, and we would not consider this because this is a negative result. So let's convert this logic into code. So we will start by creating two arrays, and this arrays will maintain the left and right max bars of each individual bar. Now we can see that for this first bar, the left max is always 0. Okay, so the left max for this 0 would be 0 always, and similarly the right max of this last element will always be 0. Okay, so the right max for this n-1 position, which would be the last position, will always be 0. Now let's calculate the left side of all the elements. So we will start from I is equal to 1 because we have already defined this left max of this 0th element as 0, and we'll continue till n. Now for any element, the maximum to its left side would be the max of this previous element and this current element, right? So that this current element can become max for some another element to its further side, which is the right side. Okay, so the left max of this ith element would be maximum, which is the math.max of left max of this i-1th element, which is this previous element, and this current element, which would be left max of ith. Okay, so this will calculate the complete left max for all these bars, and we will do the similar stuff for calculating the right max bars, and this time we will start from n-2 because the last index is already filled with this right max, which is 0. Now we will continue till our I is greater than or equal to 0, and each time we'll just decrement this I, and now the right max of this ith element will always be max of this current element or the element which is ahead this right max of I plus 1. Now we have our left max and right max for all the elements. Now we will just traverse through all the elements and check the minimum of the left and right bar, and we will subtract the height of the building at that position, which is the height of the bar. Okay, so let's traverse this array. Now here, let's check the minimum among the left and right bar. Okay, so the mini would be mat.min of left max at this position and the right max at this position, which is ith position. Okay, so the answer would be updated according to this mini, which is there, which is the minimum bar from either of the sides, and we'll subtract it from this height, which is the current element, minus the mini. Okay, so yeah, in this case we'll just define our answer as 0 initially, and this will update our answer. Okay, and we can just return our answer. And the one thing to notice is we were not taking any negative elements, so we will get any negative element if either of the sides building is 0. Okay, so if mini is 0, then we can just continue. Okay, so that we can skip any negative elements. Now let's try to submit this. So we'll first run this. So what's the error here? Yeah, it should be int array because we are defining arrays, right? Okay, so what's the problem here? Okay, so here it would be height of this I-1 and left max of I-1, because what we are doing is for every element we are checking if the left max, which is for this previous element, if this is still the greatest to the left of this current element, or if this previous element was greater, like for this particular element the left max was 1, and for this element the left max was the maximum among this part or this part, which is this, right? So similarly we'll modify this again, so it would be height of I-1, sorry, here it would be I+1. Okay, and right max of I+1, great. And here we will add another condition, like if height of this ith element, if this is greater than this mini, then in this case again we will continue. So this basically states that if the height of any bar is greater than the minimum height of the bar from the left and right side, so in this case there is no water stored, so we can continue. And I think we can get rid of this statement. So now let's try to run this. Okay, so it gets accepted. So let's try to submit this. Okay, so at last it gets submitted. So thanks for watching and subscribe to the channel for more such videos. You can also follow us on Instagram. We are on Instagram by name Hustlers Algorithm. So go, hurry up, do follow.